Hello, today we'll be seeing a really important Python property called recursion, which is basically like a loop, but you can do it in a function, which is really cool. And let's get started. So you guys might have seen this before, and it's how to calculate the factorials of a number, and you can actually do this in recursion. So here, what you just say is that this. Okay, so you're not going to understand this right now, what I'm saying. But you might see some few things. You can see that if the number is 0, we're returning 1. And that's probably the only line that makes sense if you don't know about recursion. And this makes sense because the factorial of num for 0 is obviously 1. So factorial of num for 0 is 1. So that would make sense alone. But that's actually not the reason we included it. That's actually not all of the reasons why we included it. And you'll see if I remove that and I just put in a recursion, I'm actually making a new function called recursion. And if I just remove this part, you'll see that this will happen. You will just see this. Recursion error, maximum recursion depth occur. And now if you see when I'm printing num every time, and now you'll kind of see what this does. Yeah, so basically we don't want that, so we need to make a base case. And now let me explain every line one by one, and you'll also get what a base case is basically. So in recursion, as I told you, it's a loop, and for factorial, it's a pretty easy way to do it. You can see that every number we have in our factorial is exactly that same number. So let's say we have number 5. Whatever follows it is number 5 minus 1. And for number 4, whatever follows that, and let's say that's x. And then x would be 4 minus 1, 3. And then for 3 it's 2, and 2 it's 1. So you can see here that's simple. And it always stops at 1, because if we included 0, it would just be 0. Okay, now let's see how this code works. So let's say we're putting our example of 5, and we're doing 5, okay? So 5, what the code will see is it 0? No, wait, Jose. So we'll multiply 5 by the factorial of num minus 1. And wait, if you look here, we're basically just repeating our function. We're doing a loop because we're returning num times the factorial of num minus 1. Num minus 1 would be coming back to this thing. And if you see, when I say num minus 1, okay, it's not like a whole separate variable by itself. It will go back and do this loop. So num minus 1 is like grouped together. And if you don't get what I'm saying, here's what I mean. So we're going to return 5, and then we're going to do the factorial of num minus 1. And you see that this might not be a variable because it also has minus 1 its side, but it will just say factorial of 4. So now we'll do factorial of 4. So we'll do num times factorial of num minus 1. And what I'm trying to say here is that when I'm saying that when I'm starting this, it would be wrong to say num minus 1, because that wouldn't make any sense. Like the same thing if I was wrong to just say 1. But when I am in a recursion, it's okay. So we're going to return num 5 multiplied by 4, the factorial of 4. So factorial of 4, is it 0? No. So it would be returning 5 times factorial of 4. Factorial of 4 will now go here. So it will be 4 times now factorial of 3, 4 minus 1, which is 3. So then is 3 0? No. So now we'll return 3 times factorial of 2. Because 3 minus 1 is 2. Is 2 0? No. So now I'll return 2. And you can see times 1, because 2 minus 1 is 1. And is that 0? No. So now we'll multiply it by 1 times factorial of 0, and if not, is the num 0? Yes, it is. So we'll just straight down return 1. And then finally, after we return 1, this loop will be ended, and it will give us this. So to get a better understanding of it, I'm going to show you first. Let me print it out for you just to show you how that it works. And it kind of seems like magic at first when you see recursion. 120, and it did that so quick. If I put in 120 though, now for recursion, it did that so quick too. And you can see that it's kind of like a loop. If I put 1,000, so now you'll see that, okay, 1,000 is way too much. And this is the one thing about recursion. If you're in my version of Python, it will give you a recursion error, maximum recursion depth exceeding comparison, because you're like doing it 1,000 times, and that's a lot. So if you're working with bigger numbers, you shouldn't use recursion. You might try finding a way to go past this error, or if you can't do that, you can just use the old-fashioned while loop. Okay, so now we saw some downsides of recursion. Let's see a better example of it. We're gonna do add list. So 5, 4, 3, 2, 1. And it doesn't need to be like this. It can be 5, 3, 8, 1, or anything like that. But I'm just doing this for example. So if I calculate that, 9 plus 3 is 12, 12 plus 2 is 14, and 14 plus 1, 15. Okay, good. Now let's see if it works. So first thing we have to do is that I accidentally forgot to save this file. Sorry about that. Now, let's do it. 15. Great. But what are all these numbers? Well, just to demonstrate it at you, I was printing us going down all these numbers of the loop. So I can take that off if you want, and I can see this result, which will just let it go on 15. Okay, how does this work? Well, it's very similar to how that works, except let's go back and see this thing. So it's going through every number in the loop, but not exactly. If you look at this, it's actually going from the tail of the loop to the next tail of the loop, to the next tail of the loop, to the next tail of the loop, to the next tail of the loop. And actually in real life, it's decreasing the loop. So if you know a lot of functions, you can figure out that this one is pop. And what pop does is that it not only gives you the end of the list, it also pops the end of the list off. So like it just cuts it off. And if you see now, this has actually a clear example, because first we have this list 5, 4, 3, 2, 1, and oh, I forgot to explain about the base case. And you can see if L is empty, return 0. So now, boom, it pops that off. Okay, so now we have 5, 4. So first we have 5, 4, 3, 2, 1. Okay, now it pops off 5, and it adds it with add list L again. So now we only have, oh, I'm sorry, I mean I popped off 1. So now we'll have 5, 4, 3, 2. And here it pops off 2 and adds it with, and now we have 5, 4, 3. It has popped off 2, so now we'll pop off 3, and we'll add it with 5, 4, and that's it. And then 4 will be added by, because it pops off 4, and then finally we just have 5. So pop also works if there's only one thing, Now the tail, that's the end of the list, and the head, that's the start of the list, is both the same number. So it will just pop off this and the whole number. So it'll pop off 5 plus, and here finally this iterating loop goes off, because now we're just returning 0. 0. So it's 1 plus 2 plus 3 plus 4 plus 5 plus 0. So that's recursion, and it's very important in Python, and actually lots of algorithms work on it. So yeah, bye.